Hey, in this video, I show you how to solve all problems in the practice test. Okay, so the first problem says you have two functions f and g. They ask you to find limit of f at 3. Since f is continuous, because that is polynomial, you just need to plug 3 into the function and carefully calculate this value because you have the limit of f at 3. And then they ask you to find the limit of g when x goes to 23. So that is nothing but 23 plus 4, right? And you get cube root of 27, which is 3. Okay, let's calculate this value. So I have 2, that is 9 minus 9 plus 14, right? So here's 2, 9 minus 9 is 9, 9 plus 14 is 23. Okay? Don't do wrong in this computation. And the last question is limit of g of f of x when x goes to 3. Actually, two functions are continuous, and this is a composite function. So we have very good property for continuous function. Since f and g are all continuous, limit of g of f is nothing but g of limit of f of x when x goes to 3. You see? And we already have limit of f when x goes to 3, right? That is 23. So basically you have g of 23, and we already have g of 23 in here, right? Because the limit is 3. So the answer is 3. You see? It's very easy. The second question, find the limit. So this is standard example when we study limits. The first step we need to do is plug -2 into the function. When you plug -2 into the function, you see you have 0 over 0. Okay? You have 0 over 0 in here. Once you have 0 over 0, that means -2 is the common 0 of the top and the bottom. That means you can factor the top and the bottom by x plus 0. X plus 2. So I'll do that right now. I get x minus plus 2 in here, right? And we need to figure out what's in this part and have x plus 2, x goes to -2. I have to write this right away because I want to factor the top by x plus 2. Don't forget. So when you factor that, you need to write this right away. So now let's check what is in here, right? Since you have x in here, but we have 2x in here, that means here you need 2x. Because 2x times x is 2x squared. And then free coefficient, here is 2, but here is 12, right? That means here you need 6. If you want to check back, you just multiply x with 2x, you get 2x squared. 2 multiplied with 6, you get 12. You are good. And then you simplify x plus 2 and x plus 2 because -2 is the common 0. So I get limit of 2x plus 6 when x goes to -2, which is 2 times -2 plus 6. That is 2. Okay? Next question. They give you a function f of x equal to x cubed over x squared minus 64. And they ask you to find all vertical asymptotes. All vertical asymptotes. What's that? That means you have to find all c, where the limit of f of x, when x goes to c, or sometimes c plus, or sometimes c minus, equal to plus infinity, or sometimes negative infinity. If c satisfies this, one of these cases, so x equal to c is the vertical asymptote of this function. Okay, so basically, what do we need to start? Right? I start from the following. I put x squared minus 64 equal to 0 because we cannot divide by 0, right? and we might look for limit equal to infinity over there. So I solve this, I get x squared equals 64 or x equal to plus minus 8. Don't forget about negative 8 in this case. That means plus and negative 8 would be candidates for vertical asymptotes. I say they are candidates for vertical asymptotes because there's no guarantee. Okay. In order to know which one is vertical asymptote, we need to check that condition, that definition. So for when x equal to 8, I find the limit of x cubed over x squared minus 64, right? When x goes to 8. And I see, when I plug a into this function, I get a cubed over 0. So I can tell you right away, in this situation, you just say x equal to a is vertical asymptote. Because if you have some number divided by 0, you are in one of these cases. The limit at 8 may not exist, but one side limit should exist and equal to infinity or negative infinity. Okay? So from here you can write away, right away x equal to a is vertical asymptote. Similarly, you can do that for x equal to negative a. Do that and you get negative a cubed over 0. And then you write x equal to negative a is vertical asymptote. You are done. No? I repeat again, you need to check the limit because let's remind you about discontinuity, right? This function is not continuous because we have a hole in here. The limit in this case exists and equal to a finite number. X equal to c in this case, suppose this is c, right? And x equal to c is not a vertical asymptote. The second case is this. X equal to c is not a vertical asymptote because the left limit exists, the right limit exists, and equal to a finite number, right? The last case is vertical asymptote. You take something like this, and this goes to negative infinity, or goes to positive infinity. Or maybe you go from the right, you get this picture. In this case, x equal to c is vertical asymptote. That's what we have in here. So that's why we need to check limit each time. Okay? Next problem is, they give you a function f x equal to 3x cubed minus 4, and they ask you to use IVT theorem, intermediate value theorem, to prove that f of x has a 0 in 1 and 2. So in this problem, they already give you an interval, right? And they ask you to check if the function has a 0 on this interval or not. So what is IVT theorem? The IVT theorem says if you have a continuous function and you consider that function on some interval, a and b, and suppose that the product of f of a and f of b is negative, that means fa and fb have different sides. One point is above x-axis and one point is under x-axis. Okay, so suppose we have above in here and under in this, right? And the function is continuous. Then when you connect this point, this curve should intersect with AB at some point C. This is a horizontal axis, right? And that is just x-axis. So at C, f of C equal to 0. That means C is a 0 of fx. Okay? So in this case, they give you 1 and 2. Now let's check. You just need to plug 1 into the function to find the function value, right? F of 1 equal to 3, 1 cubed minus 4, which is negative 1, less than 0. That's perfect. What is f of 2? That is 3, 2 cubed minus 4, which is 8, right? 8 times 3 is 24, 24 minus 4 is 20. Bigger than 0. You are really good. So you can imagine about the picture. Here you have 1 and 2, right? F of 1 is -1, -1 is here. F of 2 is 20, 20 is here, right? So you connect this guy and this guy, you get some C in here in between 1 and 2. And at this point, F of C equal to 0. So by using this, we say by the IVT theorem, F of x equal to 0 has a 0 in 1, 2. That's it. Okay. Okay, let's move to the next question. The next question is about piecewise functions. Okay, I have this function f of x equal to 4x squared minus x minus 3 over x minus 1. When x is not 1 and equal to 0, when x is 1. Let me write another problem right away, right? So I will remind you about two different types of piecewise function. You have second 6 and 7 very similar, so I just solve one of them. So let's take the second, the problem 6, right? Another function is f of x equal to 6 minus x, x less than 2, and then 2x minus 4, x greater than 2, here is less than or equal. Alright, so in this problem, we need to describe all intervals where the function is continuous. And in this problem, also describe all intervals on which the function is continuous. If you pay attention, so they are different. They are different by nature, right? First, this function is defined everywhere, right? Except 1. Because this function is not defined at 1, you see? 1 is not in the domain of the top function. And we define that at 1 the function is 0. So I hope you still remember this picture. Right? This picture. So we have a hole over there and we want to make that continuous. But how? Not always, right? And we need to check 0 is good number or not in order to make this function continuous at 1, right? Sometimes you add the point and you do not add to the whole. And by doing so, you don't have a continuous function. Alright? But this function, you have two parts, right? You have the left part and the right part. Okay? And again, once you have left, once you have right, and you have to make sure the left part and the right part are connected when x equal to 2. Alright, so let's solve the first one. I only need to consider at 1, right? Because at other parts the function is continuous. So I need to check if the limit of f of x when x goes to 1 equal to 0 or not. If this equal to 0, we are in this position. It's just we just fill the hole, right? But if that is not 0, so that means we add that point, but not to the hole or somewhere else. So the function is not continuous at 1. Okay, so let's check a limit of f. The limit of this guy is 4x squared minus x minus 3 over x minus 1 when x goes to 1, right? And when you plug 1 into this function, you get 0 over 0. Similar to the first problem, we can factor. Let's factor this out. You get limit of x minus 1 over x minus 1 when x goes to 1. So we factor by x minus 1, right? Because x goes to 1. And then here we have x, but here you have 4x squared. Means here you need 4x. Here you get -3. Here you have -1. That means here we have +3, right? And then you cancel x minus 1. You have limit of 4x plus 3 when x goes to 1. And you plug 1 into this. You get 4 times 1 plus 3 equal to 7. So the limit of that function at 1 is 7. 7 is not 0, which is the function value. That means the function is not continuous at 1. Overall, The function is not continuous at 1, but continuous at any point except 1, right? So how to write the answer? The answer would be negative infinity to 1. 1 is not included. Union with 1 to positive infinity. That is the answer. Okay? The second problem is easier because, we have two parts, the left and the right. The only thing we need to convince ourselves is that the function has the same left and right limits. So in order to find the left limit, I just need to take the left part, right, and plug 2 into this. So I write the left limit. If you take this part and you plug 2 into this, you get 6 minus 2 is 4, right? And you have the right limit. That means you need to take the part corresponding to x greater than 2, and you plug 2 into this. You get 2 times 2 minus 4, which is 0. What does it mean? The left limit and the right limit are not equal. The limit does not exist. That means the function could not be continuous at 2. So similar to this case, the function is not continuous at 2, but continuous everywhere else, right? So you write, instead of 1, you just write negative infinity to 2. 2 is not included, and from 2 to infinity. That's it. All right. Next question. So next question is trig functions. We need to find the limit of 1 minus cos of x over sine of x when x goes to 0. So for trig functions, I would remind you very special limit, that is the limit of sine of x over x when x goes to 0 equal to 1. Or we say sine of x and x are similar, right? That means you can replace x by sine of x or sine of x with the x when you calculate limit at 0. So in this case, you plug 0 into this, cosine of 0 is 1, right? So you have 1 minus 1, 0, 0 over 0. So you have 0 over 0. There's no way to use this limit. But if we change a little bit, the function on the top, 1 minus cosine of x, we can find the limit. So what is 1 minus cosine of x? From rectangulars, you have the following, we call double angle formulas, right? So that is cosine of x or cosine of 2x equal to 1 minus 2 sine square of x, or sometimes you use 2 cosine square of x minus 1, okay? Or sometimes you use cosine square minus sine square of x. So here is for 2x, but for x, we just need to replace x, and then here you have x over 2. You see, here you have x over 2, here you have x over 2, and here you have x over 2, right? So since we have 1 minus cosine over there, okay, anyway, let me rewrite this formula for x only. So I have cosine of x is equal to 1 minus 2 times sine square of x over 2. Sine square of x over 2. Makes sense, right? Double angle. So from here I have 1 minus cosine of x is what? Is 2 times sine square of x over 2. Now let's go back to this limit. So this limit is equal to 2 sine square of x over 2 over sine of x, right? X goes to 2. Since we are considering limit at 0, sine of x is similar to x. So that means sine of x over 2 is similar to x over 2. But here we have square, right? Don't forget. So this limit is nothing but 2 times x over 2 square over x. Make sense? So sine of x over 2 similar to x over 2, but we have squaring here, so we have squaring here, right? And instead of sine, I write just x. And you can see this limit is just 0, because here we have x squared, here 2 over 4, this is 1 over 2, right? Limit of x squared over x when x goes to 0, so that is 1 over 2 limit of x when x goes to 0, which is 0. Done. Next question. Find the one-side limit if exists. So in the practice test, you have two problems on one-side limits, right? But on the test, you will have only one. So one-side limit. Limit of 3 over sine of x when x goes to 0 plus. So when we study this topic, we talk about the unit circle. Let's remind that one more time, right? How to use the unit circle to find limits. So unit circle says this is sine a6, right? This is cosine a6. We need to consider limit when x approaches 0 from the right. Here is x equal to 0. X goes to 0 from the right means we go to 0 in this direction, right? So what happened? If this is x, right? So this is sine x, right? Sine x. So when x goes to 0, sine x just goes to 0, right? But x approaches 0 from the right, sine x also approaches 0. Here again from the right, right? He's from the right because always bigger than 0. In this direction, it goes to 0 from the left because always less than 0. So one side just goes to 0 from the right. X goes to 0 from the right. Side goes to 0 from the right. That means 3 over sine will goes to positive infinity when x approaches 0 from the right. Again, right, you can use similarity between sine and x. You can say this is limit is nothing but 3 over x when x goes to 0 from the right. And we study this we consider this from time to time. There's nothing but positive infinity. Okay? So in case, if I change, for example, x goes to 0 from the left. So what does it mean? That means x goes to 0 from the left. Sine x goes to 0 is going to 0 from the left, right? If sine x is going to 0 from the left, 3 over sine x goes to negative infinity. Okay? So in this case, I have this and I have negative infinity. All right, the last question. Limit of x squared plus 3 over x plus 4 when x goes to negative 4 from the left. So see, in this case, we have sum of two functions. For these functions, everything is good because when you plug negative 4 into this, you get negative 4 squared, which is 16, right? But how about this? This function is just similar to 1 over x. Let's say, what is the limit of 1 over x when x goes to 0 from the left? That is negative infinity, right? Because you go to 0 from the left. And I just shift the graph of 1 over x to the left on 4 units. So that's why I have 3 over x plus 4, right? Again, I consider at negative 4. So this limit, I would say the limit of 1 over x plus 4 when x goes to negative 4 from the left is nothing but the limit of 1 over x when x goes to 0 from the left, which is negative infinity. So once you have negative infinity, 3 times negative infinity is just negative infinity. Negative infinity plus 16, you still get negative infinity. So I can write this equal to 16 plus negative infinity, which is negative infinity. That's all about the test. So here you have 10 questions, but I will make that shorter on the test. Okay, maybe you would have 8 questions and 1 bonus question. So I will not tell you about bonus question now. You see that on the test, and overall you have 110 points. Okay, so hope that you enjoy the video and see you tomorrow.